We know the grid is undergoing massive change, which creates massive opportunities for local energy. The Energy Changemakers podcast offers rich conversations with industry leaders to help you and your company capture opportunities to build the decentralized grid. I'm your host, Elisa Wood. Welcome to the Energy Changemakers podcast. Hey everyone, thanks for being here today. I'm Elisa Wood, and this is the Energy Changemakers podcast. I have with me three people who think deeply about the electric grid from a social perspective, scientific perspective, and an economic perspective. And I have to tell you that whenever I have a conversation with these folks, I walk away with a much bigger vision of how energy can transform society. They're going to talk about energy democracy, what it would look like, and what stands in the way of us achieving it. You'll hear them describe common fictions perpetuated about electric power. This includes, they say, the current fascination with virtual power plants. This probably surprises you. Many people see virtual power plants as the best way to organize distributed energy. And I've certainly written a lot of articles about their value. But these folks take a contrarian view. They're not saying do away with virtual power plants. They have their place. But they're saying there may be a better way to organize distributed energy, a way that complies with the physics of the grid, and a way that would be better for consumers. So who are these intriguing people? Let me introduce you. First off, we'll hear from Lorenzo Kristov, who is well known and highly respected in distributed energy circles. In fact, journalist David Roberts recently called him a clean energy Mount Rushmore, and I think a lot of people would say that about Lorenzo. Lorenzo is an independent consultant working to decarbonize and democratize electricity through distributed energy. He was previously with the California Independent System Operator. Next up is Kay Aikin. Kay is well known for her rigorous scientific thinking about the electric grid. She is the founder and CEO of Dynamic Grid, and she is an expert in complex control systems, especially as they relate to electricity. Last, from Australia, we have Mark Paterson. He is a principal with Energy Catalyst, and like Lorenzo and Kay, he has a long history in the power sector. He was recently part of a team that has advanced several national transformation and technology firsts in Australia, including the delivery of a seminal reference architecture of Australia's national electricity market. All three, Lorenzo, Kay, and Mark, are also members of the DOE-supported GridWise Architecture Council. So, welcome Lorenzo, Kay, and Mark.
Thank you. Good to be here.
Nice to have you here. So I'm going to start with Lorenzo. Lorenzo, I've heard you talk a lot about what the future grid can and should look like. Can you paint a picture for our listeners of what this democratized or decentralized grid would be, how it would perform? I've heard you say that such a grid could work by following the physics of electricity, something we don't necessarily do right now. So please explain how localized from the bottom up energy would work and how it differs from the current way that we operate the grid.
Okay, good question, Elisa. I've been thinking a lot about DERs, distributed energy resources, how they're changing the way the power system works in really all its aspects, operations, planning, and business models, regulatory models, and so on. And one of the things that has become apparent to me over the last 10 years is that the growth of distributed resources is now, I think, an unstoppable force. They keep improving in their performance while declining in costs, and so they become attractive and cost-effective. And at the same time, grid power is becoming more expensive and not necessarily increasing in its ability to deliver any more reliably or resiliently than it has in the past. So there is this attractiveness that's happening. So where I'm seeing the industry going, in a way from an aspirational sense, is that with distributed resources, and by the way, I should say, when I talk about DERs and distributed resources, I mean anything that's an energy resource that's connected at distribution level, not necessarily on site at a customer's premises behind the meter. It could also be directly connected to the distribution utility grid as what we might call a community scale resource or a municipal scale resource. It's still local, it's still distribution connected, but DERs also include these front of the meter resources. And in my view, they become extremely important. So, what I would think of perhaps as a punchline to my vision is to say that DER technologies allow electricity supply to become a local business. That is, it's possible to own and operate local systems, local resources, community microgrids, different flavors of energy supply assets and businesses that could be integrated into local economies at the level of communities, local governments, tribes, and operated by a variety of possible ownership structures. And I view this kind of an advance as really being essential to the kinds of goals that we face in the 21st century around decarbonization, resilience, and energy justice. So if you imagine this local concept, imagine supply resources, say hybrid photovoltaics and storage, being deployed on the built environment, building them on the tops of warehouses, on the tops of schools and shopping malls and parking lots, where you're deploying energy supply in places where there are no land use conflicts, which is one of the things we are hearing more about, conflicts about use of farmland and habitats and so on. Things that would be connected at distribution levels, so don't require transmission, things that could be deployed a whole lot faster than building transmission line and utility scale generation. But we don't yet have planning models that look at the built environment as a site for deploying resources, that doesn't really look at ownership at the local level by local communities, which could build wealth in those communities. And we don't really think about supply coming from this side of the system. Most of the planning methods look at distributed resources as being behind the meter and providing mainly load response or load flexibility or load management. Now, your question about the laws of physics, where I want to go with that is the physical reality when you inject power into a distribution wires, that power flows to serve the nearest load. It follows Kirchhoff's laws, path of least resistance. And if you're injecting into a distribution circuit, then customers' loads that are located on that distribution circuit will receive that power. So that's the physical reality. But the regulatory construct is to say that if you inject power into the distribution wire, that power gets sent up to the transmission system and the bulk system operator like the ISO or RTO. And then the ISO sends power back down the same wire to serve the load. Now, by going with that fiction, it really tips the economics against the local resources, because now, even though the physics of the power flow is entirely within distribution, those resources have to participate in the ISO or RTO markets, which means ISO quality telemetry and communications and participation fees to participate in the markets. And the load that's served by those local resources gets charged for using the transmission grid, a fee on every kilowatt hour consumed or based perhaps on a demand type charge, when in fact the physical transaction is not using transmission or the wholesale market at all. So one of the things that I see as a necessary change is to enable these kinds of transactions between front of meter supply and being able to sell energy locally to local communities as a way of enhancing the economics in a way that's totally consistent with principles of cost causation and cost responsibility, because it's not using transmission, but then enables local resources to become commercially viable. So going back to the opening theme of, with DER technologies, electricity supply can become a local business. That's technologically true, but there are many barriers in our legacy regulatory and policy structures from the 20th century system that are in the way of realizing that at the moment and need to be changed.
That's fascinating. It sounds like you're saying that we are operating this grid based on sort of a fictitious premise And as a result, we're creating massive inefficiency and more cost and not taking advantage of resources that could bring energy wealth back into communities. Very interesting.
Yeah.
Kay, I think that leads right into you because I think your issue is that you believe we're actually furthering this fiction now as we move into virtual power plants. So, Kay, talk a little bit about what the problem is with virtual power plants. What's the best thing for the electric grid and for the consumer?
I think Lorenzo hit it on from a consumer-led direction. I'll probably talk more about the physics, and he talks about the nasty laws of physics. Lorenzo talks about this idea of this fiction of power going up to the transmission system and coming back down. And that's what VPP is doing. They're aggregating loads and generation down on the distribution grid and applying them to the wholesale market. And then somehow, even though physically they're not doing it, they're sending it back down as a resource down on the distribution grid. My argument is our virtual power plants really aren't, as Mark Paterson would say later in a few minutes, probably a bridge to the future. We have to understand where we want to go. And where we want to go is what Lorenzo's talking about, is a fully democratized, local, decentralized system. And virtual power plants actually take us in the wrong direction in this case. There's no implementation path that can get us there. A lot of this is because of the physics, and it's the physics of, as we transition to more and more DERs and more electrification, the distribution grid is going to get more and more dynamic. And virtual power plants respond to regional average load, not the load on circuit A versus circuit B. And what Lorenzo talks about is actually making local businesses, local distribution systems, and local networks and local consumers solving the problem. So it's a physics problem again that VPPs only make worse.
So what can we do? What is the option? How do we operate the grid differently?
So this is where regulation comes into play, where we need new regulation and we need the ability to provide value to consumers, to those edge DERs when they provide services. So if you have a EV charger and you want to charge at 7 p.m., you're going to pay more than if you have an EV charger that's going to charge at 2 p.m. Because 2 p.m. is when there's plenty of solar right now. So you actually want to charge your EV at 2 p.m. But we actually have these archaic solutions of time of use rates. And when is the peak? It's 7 p.m. For EV, the peak is a lot different than my load. I should be rewarded for pulling power off the network at 2 p.m. And we don't do any of that stuff. So we need a highly dynamic price that is on the distribution circuit that is both localized and temporal. So both time and locale, that rewards edge devices, solar, storage, EVs, whatever it is, to respond to the status of the grid.
Very interesting. And what stands in the way, as you said, is our regulatory issues.
We have the technology.
We have the technology. So the technology is a software-based technology, correct?
It's called a DERM system, Distributed Energy Resource Management System. And they can be designed to respond to local events, local distribution systems, done properly.
This is something out there in the future sometime. This isn't hypothetical. We could actually do this if we had the right regulatory system in place.
If we had the right regulatory system in place, yes.
Interesting. So, Mark, let me turn to you because I keep hearing that Australia really has it all over the U.S. in terms of being more advanced in its operation of the grid. And I understand that you're really at the forefront of a lot of the changes in thinking that are going on. So tell us what's happening in Australia and what we can learn.
Yeah, sure. Elisa, thanks for the invite. So I guess like any jurisdiction, there's some significant advances and there's also some big challenges. So we've got both. I think the headline really in Australia is that it is something of a postcard from the future when it comes to this topic of DER, or we're actually talking about DER now more in terms of CER, consumer energy resources. But to Lorenzo's point, obviously there's both behind the meter and front of meter resources. But I think there's been a conscious effort to try and get people thinking about the fact that consumers are actually much more involved in this transformation. I think on the topic of VPP, I guess maybe if I just zoom out one level and just reflect on what we're all dealing with here, which is really the transformational forces or even the disruptive forces that many other sectors have experienced, where you have the emergence of a range of new technologies, new business models, new solutions that actually create an environment where there's a product substitution option for customers. So if you think back the last 100 years, more or less, as energy consumers, we really haven't had a product substitution option when it comes to electricity. And now what's actually happening is we do have this democratization, this decentralization of resources, microcomputing, enabled energy provision. And so as Clayton Christensen, formerly of Harvard, would say, ultimately, customers will remain aligned with your offering until they find a better solution to their problem. So we all tend to want to have solutions that are going to meet our needs in the best possible way. So I think coming to the topic at hand, the reality is, a big question is, well, how do you actually transform a power system, the gigawatt scale power system, from a few hundred large scale resources to tens or hundreds of millions of participating resources? And the exam question that I like to pose to folks is, so let's little thought experiment. How do you operationally coordinate a power system that's moving from hundreds to tens of millions of resources? And that when people actually start to wrestle with that, usually there's a level of silence. This is, by the way, after folks have made some grand statements about what a beautiful future it's going to be and how everyone's going to win. And, it's just a beautiful utopian vision. But then when it comes down to the punchline question, well, how do we coordinate that system? It's, as I would say, crickets, not much to work with. So I think there's different visions as to how we would go about solving that. One of the big things that my clinic focuses on really is applying systems engineering type methodologies that other advanced sectors have used, but the power sector not so much, to really thinking through how do we re-engineer, if you like, the system to accommodate this entirely new asset class of resources, which in the Australian context, we're actually anticipating that by 2050, 40 to 50%, in the order of 40 to 50% of our generation resource will be at the polar opposite end of the system from where it was traditionally located.
DERs, in other words, will be 40 to 50%.
Correct. So here's another way of thinking about it. If you like, the DC-3 was a very stable, reliable aircraft, pleasure to fly, and so on. And in the sense we have a grid historically that we've inherited that served us well, that is essentially 1950s, 1960s configured. And so we're trying to take that DC-7 and in a sense turn it into a joint strike fighter or maybe even a SpaceX launch vehicle.
While we're flying.
And an entirely different airframe and an actual aircraft. And we're trying to do that by adding on all kinds of different elements onto the system. And that's okay to a point. But I guess my summary point would be what we're doing too little of is really just pausing while we keep the lights on, but also as a parallel path, how do we think about what kinds of ways do we want to go about leveraging this resource for the bulk power system, but also for the local distribution systems in a way that is co-optimized. In other words, that you don't, by a set of well-intended choices, unintentionally create a situation where the top of the system and the bottom of the system are somehow fighting each other. And in summary, the solution to that problem is not just going to happen by wishing away the problem. It actually requires, this is a profoundly transformational period for our power systems, one of the most complex systems humans have ever created. No other advanced sector would try and change that kind of ultra large scale complex system just by the endless accretion of issue in isolation changes. And punchline, I think to some extent, VPP models can be something like the grand panacea that's okay. Yeah, I understand there's a whole lot of complexity. Yeah, the pesky laws of physics, all of that. And what's the answer? VPPs. Okay, maybe there's some really important roles for VPPs, but have we actually thought through the whole thing, or are you just actually giving that as an easy answer to a complex set of challenges?
Very interesting.
Everybody wants the easy button.
Yeah, good point. And you would argue that actually VPPs could cause harm if we're just really relying on VPPs to the system, correct?
Yes, without a lot of communication and complexity, we will ultimately see, I can imagine a world where we're going to have 3 or 4 different VPPs with different sets of resources working in the same circuit. So data is going to have to go of what that circuit is capable of doing. It's going to have to go to 4 or 5 VPPs. There's a really good diagram we saw, I think OATI published it, of the communications transfer in order to run 4 or 5 different VPPs. And it's communications from the SCADA systems that the utilities has to all these VPPs. Then they're going to put a bid in the ISOs. The ISO is going to say, okay, yes, that's good. Then the distribution network operator is going to have to go and say, oh, no, you can't do that because otherwise you're going to blow my transformer. So everyone's only going to get 80% of what they bid. Then that's going to have to go back to the ISOs, and the ISOs are going to have to re-optimize their system because they're only getting 80% on that circuit. The process of passing data back and forth and re-optimizing continuously is going to be a computer networking nightmare.
And so where does that leave the energy user? I mean, is that something that could lead to power outages or price increases, or what happens?
Not done well, I can imagine a couple of VPPs being on a constrained circuit, all right? So circuit that's already at capacity, responding to a wholesale signal that says, we need more power. And they discharge a whole a fleet of batteries on that circuit and actually blow a DSO's transformer.
Interesting.
Well, we can't build transformers now. Where does that new transformer come from?
Very interesting. Okay, so I'm going to put all the 3 of you in charge of the grid, Australia and US. What do we need to start doing right now to bring about this grid that Lorenzo described of the future? What needs to be done at this point in time?
One place that I would go immediately is planning. Change the ways that we do planning. And by that, I mean both resource planning like IRP, as well as transmission planning. Let me focus on those 2 for the moment. First of all, recognize that in the industry, there is a bias towards building big projects, transmission lines, utility scale power plants, remote from load that require transmission, and so on. That's where the big money has been for 100 years. And the parties who made big money building those kinds of things want to keep the focus on building big infrastructure. As we plan, say, transmission, or as we plan resources, that means that the planning methods are not going to recognize alternatives in a way that actually recognizes their values. So we see planning methods, say transmission planners at ISOs. And I worked at California ISO when we reformed the transmission planning process there. And part of being able to plan transmission is to know how much demand will the bulk power system see. How much demand it sees depends on the deployment of distributed resources. So if you don't have good planning scenarios that look at high DER growth rates, not only customer adoption of solar PV and electric vehicles and batteries, that's the customer side, but also an incentive structure in the regulatory framework that encourages deployment of distributed solar and storage resources at distribution level that are, say, on the roofs of warehouses and other buildings using the built environment, so on. If we don't encourage that kind of development, then we won't see it in our transmission planning exercises. We will just have an assumption in transmission planning that underestimates the potential value of distributed resources and thereby procures or designates for development more transmission than would actually be needed if we had a vibrant distribution side. So I think one place to focus effort is different planning methods, both for IRP and for transmission, that incorporate high distributed growth scenarios where we actually build out the technical potential of PV arrays on the built environment and regulatory rules that encourage the behavior of those resources in a way that supports grid operation.
So we're basically leaving resources on the table right now in our planning. We're saying, oh, we need to build this much transmission, this many power plants in order to meet all of this massive demand coming in from AI and EVs, but we're not looking at the other side and saying, oh, actually, we could build some local energy over here and avoid the construction of these big power plants. And that's really the problem starts at the planning level.
That's right. And that's why I use the term bottom-up planning in a way to think about, as you look at the needs, what's driving the demand for electricity. Certainly electrification will be a factor, but then the next question is how much of that new demand can we meet locally? Instead, the existing planning methods just assume that all this growth in demand from electrification and data centers and those sort of things, assume that all has to be supported, provided by the bulk power system. And then that leads to overemphasis on building big transmission, which is problematic in another way because it takes forever to build transmission lines. And it's very controversial about siting big wind farms and solar farms on habitat and farmland and so on. So, and yet the planning methods don't even look at building DG on the built environment.
I feel like this is a really crucial point because I feel like we're almost shamed into saying in the US right now that we support transmission. Because if you don't support transmission, you don't support renewables, because the argument is that you need to have the transmission in order to get the renewables to market. But as you're pointing out, there's this whole other path that's not being seriously considered.
That's right. And I'll just mention there was an NREL study in 2016 that looked at building out PV on warehouses and big, large-scale rooftops all over the country. And at that time, they found something like over 30% of kilowatt hours on an annual basis for the United States could be provided from this distributed solar resource. And in California, the number was more like 70%. You know,
and that's only on warehouses, right?
That's just looking at big rooftops. I don't know what all was included, but it was basically big rooftops where you could deploy significant size solar that's distribution connected. It could supply a huge proportion. It doesn't mean we're eliminating the bulk grid, but we're planning it for the residual supply after meeting as much as we can locally.
So it becomes a backbone.
Yes.
Mm-hmm. Yeah. Good.
Elisa, I was going to add to Lorenzo's points there that I think one of the big challenges we've got here is humans just don't do large-scale transformation particularly well, like in any sphere. And what we tend to do is we live most of our lives in a fairly incremental kind of step-by-step way, which is perfectly fine. That's the way life is generally. But then when you come into these large-scale transformations, it's kind of like, what do we do now? And well, let's look busy with lots of activity and I hope that that's all going to give us the outcome we want, a net zero emission system or whatever. The reality is that those kind of transformations don't just happen by osmosis, that we actually need to lean into these processes and we need to actually get our thinking straight for a start. To actually, what we really need to look at is these transformational changes they're not peripheral, they're structural, they're fundamental. They're really changing the very nature of our electric power systems. And so what we need to actually be thinking about is if we could frame this as a 10-year transformational challenge. And let's think about, yes, we need to keep the lights on, because this is another part of the story that tends to be a bit of a red herring, that we don't have time for any of that, Lorenzo and Kay, because we've got to keep the lights on. Don't you understand? This is urgent. We're desperately working very hard on that. Of course, that's critical. That's absolutely mission critical. But at the same time, we don't have the luxury of kind of therefore just look busy and hope that this kind of gets us there. We need to actually create parallel processes that actually enable us to think about how would we best utilize the next 10 years, the next decade, to really fundamentally transform our power systems? How do we create the societal discussion required to actually do this, to really debate the kind of vision that Lorenzo and Kay are setting out, hear the competing views, make societal decisions about how do we want to configure this system? Let me just add one other thing that has not been mentioned, I think, in that discussion so far, is that one of the challenges, fictions, if you like, is that we talk about the market and we want to extol the virtues of what markets can do, and I'm there. But the reality is our market structures, as well as our regulations, but our market structures were designed in a world where all of the generation action was happening at one end of the system. Now we're trying to actually, if you like, shoehorn this thing called DERs into that environment. And the reason we have this fiction of the sort of value of those DERs needing to be monetized at the wholesale market is because essentially there is no market construct for valuing those resources actually where they are. And for the services, according to Kirchhoff's laws, would be able to actually be provided locally. And okay, so what do you do about that? Easy answer, bolt on some VPPs. That's not actually a comprehensive answer, because at the end of the day, as Kay was saying, you can end up with a situation where, well, how many VPPs can we have operating on one circuit? And what does that do to the actual operational performance of that part of the distribution system? And a whole range of other attendant questions. So, summary, we can't actually navigate this transformation without building out strategic transformation processes that are respecting the fact we need to keep the lights on in the present, but actually doing the hard work of collectively rethinking how do we want to configure our power systems over this next 10 years, because it's going to take time, but we actually need to provision them for quite dramatically different futures. And the accretion of incremental changes ain't going to get us there.
And these changes are so much more than just physical changes or software changes. I mean, we're kind of getting to the heart of the way we think about how we pay for power and who gets what kind of incentive to do what. For example, we all know that the transmission is great for utilities, building transmission, because they get a great return on that. So there's the physical aspect, and there's also the economic and the regulatory aspect. There's a lot to deal with here in creating this sort of 10-year vision.
It's a whole ecosystem, and it's a lot of my start in this really was in the study of sectoral disruption generally. And I think that's what we're underestimating here is the power sector, the global power sector, which is such a critical infrastructure in all of our societies, is undergoing very profound structural transformation. And often a lot of our activity almost pretends that's not actually happening at that scale. And I would just, as Kay mentioned, a lot of this comes down to our theory of change. Is our approach to change and transformation in any way commensurate with what our policymakers are saying we're doing with our power systems? Is it actually going to get us to a net zero emissions future, for example, if that's what a jurisdiction is pursuing? In many cases, it's absolutely not. And we're not actually applying the tools to really give us rigorous answers as to how do we actually get from where we've been to where we need to go.
So I'm assuming that this is a lot of what you work on in the Gridwise Alliance. These are the issues that you're dealing with.
We try. There's a small group of us, and three of the small group are the ones pushing hard on what I would call transition engineering. Is really how do you look at complex systems and how they transition over time. And that's really Mark's superpower, and somewhat to Lorenzo and I. Lorenzo is a big thinker about how consumers should interact, and I'm a little more about how does the physics work. You asked a question, Lorenzo, and I'm going to kind of three things, if I had a magic wand, that we need to do. And one is what I would call what Lorenzo alluded to, which I say is performance-based regulation. And that is, what's the cheapest asset and the cheapest infrastructure improvement I can make to solve the problem. And right now we have a system that is, how can I spend the most money to solve the system? And that's what we're doing with transmission. The next one is dynamic pricing. We need to find the way to transfer value for electrons used at the right place at the right time. If we can figure that out regulatorily, the system will work that much better. And then the last one I already mentioned is this idea of energy transition. And that's what we work on with the Grid Architecture Council, is how do we transition the system from where it is today to the future that we imagine? If we could do those three things, we've got it licked.
If we could, just those three things.
Just those three things.
Are there any jurisdictions, places that you look at as promising, like, hey, they seem to be moving in the right direction?
I think Australia is. They have something called dynamic operating envelopes, which they're starting to put out, which is the idea of kind of a temporal and locational limit on what you can use. So at every hour of the day, you're told this is how much power, how much capacity you have at your location. It's one method for solving this problem of what I call lumpiness in the system. As we get more and more DER, the system's going to become raisins and oatmeals. And very often you take a scoop of oatmeal and you don't get a raisin. And other times you might get 3 raisins.
Interesting. So these envelopes, what happens if you reach capacity? Is there some kind of restriction that occurs, or what is it, a pricing thing?
It's basically a pricing thing.
Okay.
Mark can probably talk more about it.
Yeah, so there's a lot of work occurring here on dynamic operating envelopes, which is a flexible export management sort of mechanism. There's a number of different variants on how that's being applied. It's a technological solution that's been developed primarily, or at least originally, with a focus on managing local distribution level capacity. And that's now, if you like, because we're a vertically disaggregated market structure, somewhat like ERCOT, you end up having different parts of the system working on different specific challenges relevant to their particular part. One of the challenges that there's been some effort to really look at is how do we get all these parts working together? And so there have been some large scale projects such as Project Edge, Project Symphony, and Project Edith, 3 different sort of projects that have attempted to span the end-to-end power system. I think to your question about jurisdictions, my firm has a privilege of doing some work internationally in Europe, UK, interacting with the US and obviously Australia. And I think different jurisdictions all have different strengths and weaknesses as to where they're at. And it's really a case of taking the best from different locations. Like, for example, Europe and the UK quite advanced with what they call flexibility markets at the distribution level. So in other words, creating market constructs for valuing the localized resources in ways that just the dependence on the wholesale market can't do at that. Because as both Lorenzo and Kay have been indicating, that the value of what DERs can do really comes down to a simple equation of where a customer chooses to participate. It's about the right physics-based service delivered at the right time at the right location. And that now actually multiply that by tens of millions of resources, and you can actually understand the nature of the coordination challenge, which is really at the heart of this whole thing. So in summary, I would say there is, I think the biggest risk to this transformation is confirmation bias. In other words, that we keep looking at these challenges through the lenses of the 20th century toolkit. In other words, and this is where we go back to the only answer is transmission. So are we saying that transmission doesn't matter? Of course not. What we are saying is that, yes, there will need to be transmission augmentation. But are we actually fully leveraging, is our thinking, is our planning processes, are our regulatory mechanisms, are our market design configurations, are they actually leaning into the fact that we've got an entirely new asset class showing up in the millions on the polar opposite end of our system? And how would that offset and mitigate the need for very expensive capital build. I think that's what's getting undertreated, and it certainly shows up in the way that we still continue to try and prop up 20th century mechanisms to solve 21st century problems.
Not only underestimated, but also sometimes treated as a nuisance, like, oh, these DERs are on my system and where I can't see them and what I can do with them. And so as opposed to looking at them as a resource.
Ruining our beautiful system.
Yeah.
Well, you actually pick up a good point, is the idea of visibility. Every utility operator is going to say, well, I need full visibility. They actually don't. 100 years ago, they had no visibility. Their only visibility was, what's my voltage at my generator doing? But we've now gotten to a paradigm where the only way we can operate is if I can see the power flow from every single thing that's connected to my network. And that's nuts.
I was just going to say, you asked about examples of where things are going in a good direction. And I think there are three things I would recommend listeners to check out. One of them is to look at what certain co-ops are doing to reform their distribution utilities. My favorite that I know a bit about is Holy Cross Energy in Southern Colorado, which is really accepted the notion that their distribution utility is going to become a facilitator of distributed resources, is going to enable them to interconnect in a streamlined fashion, enable them to transact and supply energy and grid services, and shrink its own role as a distribution utility to mainly providing the platform, providing the network, providing the markets for parties to interchange. So look at Holy Cross Energy. I should also mention that as my thinking has evolved on all of this, I think that the key to really realizing the full value of distributed resources for customers and for environmental goals and for things like resilience is to create a transactional marketplace on distribution, that it's really enabling DER owners to economically participate in the grid through transacting energy and through transacting grid services that then releases the value of those. And so I've described the key to this transformation as reforming the distribution utility to become an open access DSO, distribution system operator, which there's not one definition of that, but it does reflect a future for distribution utilities that's far advanced of the traditional distribution utility role, which has always been just one-way delivery of kilowatt hours. So I'll note it as my second example that the state of Maine last year passed legislation to do a study to look at feasibility to create a statewide DSO that would become the operator of all the distribution utilities in the state and manage the interface to ISO New England, which is the ISO where they're located. And the question for feasibility is, could such a structure reduce rates, improve reliability, achieve environmental benefits, and enhance the proliferation of distributed resources? And if so, what would such a model look like? That study is taking place this year under the governor's energy office in Maine and is supposed to be finished in a report by the end of this calendar year. So that's the second. Another that I would encourage people to look at is the metered subsystem model that exists in the California ISO. This has been around since the 90s when the ISO was first formed. But what it essentially does, it's for municipal utilities that run distribution systems but are embedded inside the ISO balancing area. They're embedded inside PG&E or Southern California Edison. And so they're reliant on these investor-owned utilities for access to the grid. The unique thing about the metered subsystem model is that this municipal utility can do whatever they want in their local area to use local resources to supply load. And their interface with the ISO is entirely based on what's going across the transmission distribution interface. It's that net consumption of how much they import from the ISO that determines their relationship with the ISO. It's not, as in most other areas, where the ISO has visibility all the way down to end-use customers, distribution-connected resources, and so on. In many ways, this metered subsystem model is a working instance of what this future DSO model could look like.
That's pretty fascinating. Interesting. Yeah, I loved all three of your examples. Maine, of course, is really jumping ahead of everybody else with its DSO platform, and
We're hoping.
we're hoping, yeah, but it's at least moving on it, right?
So Lorenzo didn't do justice to that. I helped write the bill, and Lorenzo and Mark are on the study committees.
Very good, very good. Look forward to hearing more about that then. And then Holy Cross is a great example of a utility that's not fighting the future, it sounds like, but actually planning for it, which is what we talked about at the very beginning, the need to plan.
I think that's right, yeah. Of course, they're a co-op, so they're not under a regulatory commission, and they're owned by their customers, not by remote shareholders.
It does seem like the co-ops have a lot more flexibility to move forward on some of these ideas than the electric utilities.
Though less
And
money
too.
generally, they have less money to spend, which is a part of a problem.
Interesting.
Elisa, I was just going to say that I think some of the discussion too has highlighted that obviously different jurisdictions have different market and industry structural arrangements. And so I think that there's a number of topics that kind of are universal across all market constructs or industry structure sort of arrangements. And I think a basic one is one that Lorenzo mentioned, that a few of us have mentioned, is the monetization of the value of DER services at a local level is a really critical dimension, and just dependence on 20th century rate type constructs is inadequate because we're dealing with a kind of spatial and temporal dynamics that really needs to be properly reflected in the market monetization. So localized valuing and monetization of those services is a really critical dimension. In a vertically disaggregated market like Australia, for example, perhaps that's an important addition to any kind of viable model for VPPs, is that ultimately, if a VPP is in a sense functioning to virtually reaggregate the value streams of resources at the different levels of the system, then that would certainly be far more effective and feasible if in fact you've got an appropriate way of monetizing the value at the different layers or tiers of the system. Right now, we've only got a market construct at one end of the system, and we're trying to actually fabricate or construct some proxy version of valuation at the distribution level, which is always going to be suboptimal. I think that just goes to the question of, we can't put off forever the fact that we need to think about what's the structural arrangements required to fully enact the value of these resources without creating a whole bunch of other unintended consequences.
It sounds like you're saying there's almost a possible VPP 2.0 kind of approach if we could bring more temporal and locational pricing to VPPs. Did I understand you correctly?
Yeah, I guess my main point is that personally, I wouldn't say VPPs are a good thing or a bad thing. I think, like anything, where something gets put forward is almost like a magical panacea. A whole set of complex problems. What's the answer? VPPs. Next question. Totally inadequate. Totally inadequate. Okay, I'm not actually saying VPPs don't necessarily have a role. In fact, I think they're quite an inspirational solution. But I think where you actually try and superimpose that on a set of arrangements that have some fundamental limitations and gaps, you're really just putting band-aids on things. So, yeah, I think collectively, the main thing that all three of us really are very passionate about, we have some differences in different sort of nuances. But one of the things we're very passionate about is, please can we have a grown-up conversation and processes for thinking holistically about this critical, highly complex societal systems that are meant to actually serve us as citizens. Can we please actually have some processes that reflect that kind of complexity? Let me just give you one other data point that is encouraging here on this side of the Pacific, and that is our federal government Commonwealth Department has been given the responsibility of developing a national DER or CER roadmap. And a number of parties is privileged to kind of leverage some of the work we've been doing on systems architecture and so on, just to help inform some of that planning. So watch this space over the next coming months, but certainly Australia is now in a process of leaning into how do we more fully leverage this. I think it'll be a watching brief as to how that all plays out, but Ed, happy to keep you abreast of that as well.
Mm-hmm. Let me add something to what Mark was saying, because he and Kay both are pointing to some really important principles here. In my view, there's a fundamental message that needs to come across here, which is that ultimately the value of distributed resources is not as wholesale market resources. That's where they go, because just like that's why Willie Sutton robbed banks, that's where the money is. But that's kind of a leftover feature of the 20th century. The value ultimately of DERs is going to be local in one form or another, and in many different forms, whether it's local ownership, local businesses, or even a VPP concept at circuit level where you're coordinating resources to flatten the net production profile or the net load profile on a distribution circuit in order to avoid upgrading that circuit. The value of DERs, initially, utilities have to invest in visibility, control, situational awareness, all of that stuff to be able to see what's going on. But once that investment is made, the payoff of DERs is going to be avoiding building grid infrastructure. We're meeting more of our needs locally, and that's where the real value of DERs comes through. So this aiming them towards wholesale market resources is a natural way to go, but it's very much a continuation of 20th century thinking that all of the resources are managed by the bulk operator. And that's just an outmoded value proposition. The new value proposition is creating this transactive open access marketplace at distribution level and using them and then incorporating all of that into our planning methods so that planning is now looking at the bulk system as residual and not looking at it as primary supply. And we're looking at how DERs can offset infrastructure investment.
Get the prices right, get the system right.
Very good. I could talk to you all about this all day, and I really want to ask you about FERC 222 too, but I've had you here for an hour, so I'm feeling like I should probably end it here. It's fascinating. We have to do this again. There's so much more to talk about here. Really appreciate the thinking of the three of you. You are just so cutting edge, and you definitely have superpowers, I'm convinced. So thank you for being here. Thank you for joining us today on the Energy Changemakers podcast. I hope today's conversation has inspired you to think differently about the role of distributed energy in our society. If you enjoyed this episode, please subscribe to our podcast on your favorite platform and consider leaving us a review. You can help us shape the dialogue around energy. Go to energychangemakers.com, subscribe to our newsletter, and join our community. Together, we can make a real difference in how quickly we can make our grid local, equitable, and clean.